afternoon, everybody. Very nice to be with you. I would like to associate to this presentation Asias Kwazon from the University of Botswana, who contacted me about this talk, and the people from Mauritania, who love these Richat structures. It's called also the Eyes of Africa. The Richat structure in the Saharan Desert, it's a spectacular example of a magmatic structural structure, which is in fact the very apex of magmatic plume. So where is it located? Is it located in the Sahara Desert? You see the western coast of Africa with Dakar, Nouakchott, and the Richat is clearly seen on these aerial photographs. It was discovered by the pilot from the Gemini 9 expeditor from the NASA. And when they saw that, they called it the Eyes of the Sahara. It was in fact not known before, because from the ground, it's very difficult to see it. But from satellite, it's very easy on the Google map either. So geological context, we are in the border of the Taudeni Basin. The Taudeni Basin is a very large structure. It's 2 kilometers to 6 kilometers deep, filled by sediment from the upper Proterozoic to the Paleozoic. And on the edge of this Taudeni Basin, that go from Algeria, Mali, and Mauritania, you have a dome from basement structures going up. And the Richat is just located nearby the Wedan city, which is one of the UNESCO designated heritage, because there is a very old manuscript from the Middle Age keeping the Arabic tradition on this area. So the Eyes of Sahara, what it's composed of, it's a very large structure, 40 kilometers in diameter, where you see several cliffs, 3 main cliffs, from outside to outside, on the border, a very large dune area. It's rather difficult to access. It's pretty remote, and in fact, it's still preserved because the area is pretty much inaccessible. So geological mapping shows that, in fact, it is composed of a dome, where you have from the very inner zone, you have sediment, which are the older one, and going outward, you have sediment which are more and more recent. So going from in the bottom, mainly Proterozoic to Cambrian, and moving to more recent sediment going outward. So clearly a very clear domal structure, very regular, and this zone is cross-cut by numerous magmatic and volcanic rocks that were discovered 20 years ago when we mapped the area. And in fact, it's clearly the indication of a mantle plume structure with different expression in the dome area. This is a geographical section that was published by Abdenan and co-authors last year. And what we recognize a magmatic intrusion. In fact, it is 100 million years old. Then we have the Proterozoic chart group, which is the basement of the Taudeni Basin. The Atta group, which is well known with a stromatolite formation, very, very beautiful stromatolitic formation, and the upper Paleozoic formation at the outer zone of the area. So this is based from 2D magnetics and gravimetric modeling. So when we look to these structures, it is composed mainly of 4 generations of magma. We have some kimberlitic structures with diamond associated with in the outer part, very, very small and remote occurrences. We have basalt forming 2 ring dikes around the area here. Then we have rhyolitic dikes indicating some kind of crustal volcanisms at the top, at the very center, and we have a full set of carbonatites. So you see carbonatites, rhyolite, basalt, and kimberlite. We have the whole spectrum of magmatic rocks. It's like a magmatic museum, in fact, in the heart of the Sahara. So you see clearly on this magnetic map the 2 ring dikes, very clear, area. They were dated at 99 million years. The carbonatite is this small outcrop. In fact, there is no large diamond, but it's very clear that you have some very deep magmatic rocks coming and making seal. The carbonatites have a whole collection of inclusion coming from different levels of the crust and the mantle. The volcanic basin is very specific. It's a small 1 kilometer square kilometers in formation with a lot of formation and some remnant of plant that make these gang rings all around, circular structures. And it's very fascinating for the people from the area to see that people see round structures from the top and round structures from the bottom. So it's very funny. And there is a big mar. You can see it on this geological map here. Here. Which is a typical mar with an envelope of breccia, and it's still unrecognized. I would say there is a subcra on it, and we have no data on these structures. At the top, at the very center of the Richat structure, there is a very large breccia, and this was a puzzling structure because, in fact, if it was, it could be some meteoritic impact or explosive breccia and whatever, but it doesn't like that. It's composed of mixed fragments, some silicified, some not silicified, and it forms a very huge area here, 1 kilometer in diameter, up to 50 meters in thickness. So probably one of the largest breccia I ever see in the world. And the question was, where does this breccia come from? How it has been formed? So you see some part of the breccia are sedimented. And these sediments are hydrothermal sediment, potassic hydrothermal sediment, that were dated at 99.2, so same age, than the intrusion, and this sediment are clearly hydrothermal sediment. Within the breccia, you see slump, and that's very unusual, That means that, in fact, it was a big cavities, and the cavity was filled by breccia. This was unstable, and some of this slump occur in zone where the breccia was slumping down within the in zone. So it's a big hydrothermal cavity formed by hydrothermal fluids at the end of the magmatic event. So why it's significant? In fact, the 100 million year event is a big event. Cretaceous is a very special period, and you found this kind of magmatic plumes all around the Atlantic, from Mauritania to Namibia to Brazil, and even in North America, the Mont Royal, downtown Montreal, in fact, is a gabbro intrusion 100 million years old. So in fact, it was the same event all around the Atlantic, probably formed by edge convection. So it's also a place of heritage, which that has been inhabited by people since the Alkaline zones, where a lot of silex and so on. So still poorly known, I would say. So the Richat was in fact disputed. It was Theodore Monod was thinking it could be a dome. Gemini 4 called it the Eyes of Sarah astroline. In 2000, Ashton Mining makes some diamond exploration. We recognized with one of my students, Guillaume Maton, that it was a mantle plume, and now we're very clear with the geophysical modeling that it's clearly a magmatic structure, one of the nicest, I would say, uneroded magmatic structures in the world. It's like a giant labyrinth, and in fact, the Mauritanian people have said that it's the highest geosite touristic value in Mauritania, published last year. The people from Republic Islamic of Mauritania are in the process to make a reserve area. It could be a park, it could be a geopark, maybe one time. It's very important for Mauritanian people. And was the main argument for EUGS recollection? It has been a case of scientific debates about the O-ring of ring structures. Is it an impact or is it intrusive? It's a contrasting landscape on the wider, almost flat Sahara Desert. It's a kind of unique petrologic museum of a deep mantle, and it's one of the most spectacular examples of magmatic-induced ring structure in the world. So thank you for your attention. I can tell you in Pula, in Soninké, in Wolof, in the different language of the Mauritania. Thank you.